Hello everyone and welcome back to Coding with Lying. It's been a little bit of a while since the last time I did an update video on this because I've mostly been tinkering around and fixing things in the background, but here we are in the Neuro Entity Flee task. This is what our Neuro villagers use to flee from zombies. And you can see I've got print stream in here. That's temporary. If I can actually get this thing to work properly, and I'll explain what's up with it in a moment. This is just to tell me exactly what data is being processed. But down here, the first thing that we need to note is we are no longer using junk data for the neural network. This is a 4-neuron network across 2 layers, which is replicating the Boolean logic that the standard flee task uses for villagers. So it is looking for a specific number in the let me see if I find it. Okay, there we go. Target entity.hashcode. It's looking for a specific entity ID that the entity is actually looking at, and then it is looking for whether the distance from this entity to that entity is less than 16 blocks, which is to say close enough to consider starting to run. Now it's important, of course, to ensure that this neural network system can actually replicate the Boolean values in the existing tasks, in order to show that it can actually replicate the current capacities, capabilities, and levels of function. Once we've gotten that sorted out so that we have a neural network that is imitating perfectly the Boolean version, we can then start to add more interesting features and get them to change over time, thereby to expand upon the function. The next thing that's changed is down here. You see, instead of just adding the basic value itself, I have exchanged this for the value greater than 0.75, if so return 1, otherwise 0. And that is what is called a threshold value. That is, if the neuron is getting this degree of input, then it triggers, it sends a signal. And that means that it makes it a lot easier for our network to do Boolean, and it also means that we can still keep all of the fuzziness from the different levels, because remember, we're still using very small numbers, generally speaking. So let me see, this one is looking for whether... The way that I'm doing Boolean logic is if a number is greater than or equal to a certain number, or if it is not triggering, basically. So here we have the value required to get is a greater than or equal to 54, and then this one is for greater than or equal to 55. Now what happens when this eventually reaches the final layer is we have these 2 neurons, which now that I look at it might be why I'm crashing so much. Anyways, and they are looking to try this neuron can only trigger if this first neuron returns true, but these other 2 return false, because this is greater than or equal to 16, this is greater than or equal to 55. So if the number is greater than or equal to 54, but not greater than or equal to 55, since it's an integer, we assume it must be 54. And by using greater than or equal to and not, which is what I get by subtracting it, then we get the system where we can do Boolean values. The current bug I'm having is happening right around here. More or less. It's happening... there it is. It's happening right as I try to parse an int, because apparently at some stage, I'm not entirely certain where just yet, we get an empty string entering into the equations, which means that parseInt breaks, basically. Because it needs to have a string of at least length 1, so they can try and fathom out what the actual value is. But once I sort that out, our next step is to effectively cut out this should execute, because that's where all of our interesting stuff is happening, and grab the end data, of course, and then insert that into a wide range of other tasks, replicate the Boolean logic for all of them using the neurons, and then we will have entities that are using neural networks to replicate perfectly, ideally, the Boolean behavior of the existing task system. Then we can start adding in the learning system so that they will actually start to change their behavior over time, and then we can get them to start breeding it properly. I have about 3 or so weeks to get all of this done, so I'm a little bit worried, but then I'm very prone to worry. But anyways, that is it for now. If you have any ideas as to where that blank string is coming in, it might actually be this last neuron, I'm not 100% certain, then do let me know. But other than that, I shall catch you all next time.